welcome. Now I'm going to try to finish up our 5-6 notes with the word problems that are at the end. Basically, the only thing you need to be able to do here is set them up, and then the rest of it is what we were doing in the first 4 problems. So let's get started. I've got example 5. I've got a rectangular solid. This is to be made so that it's length. Well, first I'm going to draw a solid here. And this one I've got a length that's supposed to be kind of big. So I'm going to draw a solid that sits like that. And it's going to be bigger than the width. Ooh, poor job there on my part, but we're going to go with this. So it says the length is 4 times the width. So it's comparing the length to the width. So that I want to start with width being my variable. So in that case, I'm going to say width is x, and then the length is 4 times that. It says the height is 3 more than the width, and I'm glad that it continued to compare to the width, because that's what I said x was. Width was x. So my height is x plus 3, and it gives me a volume. Well, a volume is simply length times width times height. So length times width times height, make sure you use quantity, has to equal that volume of 3,888. Well, I'm just going to simplify the left-hand side here. I'm going to turn 4x times x into 4x squared. I'm going to distribute the 4x squared, make it 4x cubed plus 12x squared, and that equals 3,888. Well, when you're doing these word problems, you got to remember that you're trying to put yourself in a situation to find out the zeros. And to find the zeros, you need to make this equal 0. So bring over the 3,888. That tells me there's 3 solutions, there's 3 x's that could work, but I don't know if they're all real numbers or not. There's only one that I'm really interested in. How am I going to find that? I'm going to go to my calculator. I'm going to plug it in, because I certainly don't want to list the factors of 3,888 and 4 and get all the possible rational solutions and start trial and error like I did back in my day. I'm going to use the calculator. I'm going to go to y equals. I've got that in the y1. I've got the first one typed in. So I'm going to go ahead and just hit graph and hope that it fits in the graph. And look, it does. I don't have a great view of the graph here, but I see there's some graph right here, and it's crossing right there, which looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to look at the table just to verify that 9 is a 0. And lo and behold, 9 is a 0. So it looks like x is 9. Now again, on your test, I'm not going to be satisfied if you just say, oh, I put it in my calculator and x is 9. You know, I want you to prove that 9 works. So go ahead, plug 9. You go 4, 12. Don't forget the 0 spot here. You're going to have a problem because there's no x term. So you'd have to drop the 4, 36, 48. 9 times 48 is not the same as 9 times 50 minus 18. So that'd be 450 minus 18. That'd be 432. Add 432. And then you might want to verify that 9 times 432 is 3888. Looks good. Looks like I could have taken a 4 out here also at the beginning. Maybe some of you have noticed that. That would have made my numbers smaller had I taken a 4 out and worked that way. Wish I would have noticed that right away. I forgot that. Oops. But I could have taken a 4 out, got 9, 7, 2, and then it would have had smaller numbers to work with. So I could take the 4 out here as well, because this is 4x squared plus 48 plus 432. You could take the 4 out now, but now let's go ahead and do that and see if that helps. So I have 4x squared plus 12x plus 108. Then the question is, can I find anything that multiplies to be 108 and adds up to 12? And I'm thinking no. Okay. For it to be a small number, the numbers actually have to be pretty close. So what are factors of 108 that are pretty close? That'd be 9, 12, 9 times 12. But 9 plus 12 is 21, not 12. So if I were to do the quadratic here, looks to me like I'm getting imaginary solutions. So this part here doesn't matter. I'm interested in the fact that 9 worked. I only really wanted one real solution anyways. 9 worked. It gave me 0. So x is 9. So the width is 9. The height is 9 plus 3, 12. And then the length is 4 times 9, 36. So there's your 3 dimensions. Example 6, basically the same thing. I've got a rectangular shaped swimming pool, so it's, we're just talking just like we just did there with a rectangular solid. It holds 8,000 cubic feet of water, so its volume is going to be 8,000. The width of the pool is 1 more than 3 times the depth. So we're talking about the depth. We're comparing to the depth, so I'm going to have my depth be x. This is the width of the pool is 1 more than 3 times the depth. So that'd be 3x plus 1. Obviously, didn't draw this one to scale. I should have made this a lot wider. But 1 more than 3 times the depth is the same as 3 times the depth plus 1. And the length is 5 times the depth, so that's 5x. So we've got the same problem here that we did up there. We're just going to take length times width times height. I'm going to put the height first. Then it's a lot easier to do 5x squared. Then distribute and get 15x cubed plus 5x squared. That equals 8,000. Make it equal 0. This one, so it equals 0. I'm not going to get fooled this time. I'm going to take a 5 out. 5 goes in always. 1,600. And then I'm going to use my calculator to come up with a possibility for x. Y equals, turn this one off, arrow down. This second y2, I didn't take the 5 out, but it doesn't matter. The roots should be the same. So I'm just going to turn that on, press graph, say, oh, looks pretty close to the last one I got. This last one was 9. So this one is 8. 1, 2, 3, 4, 5, 6, 7, 8. Crosses at 8. So here we think x is 8. So we think x is 8. So we're going to go ahead and test to make sure x is 8 works. Let's put that in synthetically with these numbers here. So 3, 1, 0, negative 1,600. 3, 24, 25, 4. Ooh, hang on a second here. 8 times 25, I was going to put the wrong number there. That's 200. There we go. Add that 200, multiply 1,600, there's 0. This right here, we don't really need to worry about because I don't need multiple answers. I just needed to prove that 8 works. So x can be 8. Therefore, my length could be 5 times 8, 40. And my width would be 3 times 8 plus 1, 25. There's my dimensions. So this is the idea on the word problems. You get them set up and then make it equal 0 and use your calculator to find the 0 and then just prove it. The next two are a little bit different because you got to understand how to write consecutive integers. So here I'm talking about 3 consecutive integers, like 1, 2, 3, that's consecutive. They're right in a row, 1, 2, 3, 3, 4, 5. How would you write them algebraically? Well, you could say the first one's x, in which case the second one would be x plus 1, and the third one would be x plus 2. So you could say I want to multiply consecutive integers. x times x plus 1 times x plus 2 and get 990. Well, I'd probably FOIL these first and get x squared plus 3x plus 2. I distribute the x and then make it equal 0. Use my calculator to get an x to test to make sure that it does in fact work. And I'll see if I've got that one in here. Y equals, get this second one turned off, we're done with y2, and y3 is what I'm looking for. So let's hit graph, and it came out way over there. Looks like we're back at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got another answer of 9. So x is 9. What does that stand for? That stands for our first number. So we think the numbers are 9, 10, and 11. Those would be consecutive, 9, 10, 11. That's pretty easy to see that it multiplies to be 990. But I still want you to prove it synthetically on the test. So make sure you take the 9, plug it in, 1, 3, 2, negative 990, and show that when you do the synthetic, you get a 0 at the end. Then we can all be happy, happy, happy. This is what I would expect most people to do if we're writing consecutive integers. Do x, x plus 1, x plus 2. But some of you are pretty darn smart. So I'm going to show you what would have been better. And that would have been first number, second number, third number. It would have been better to let the second number be x. Why would it be better? Well, let's see. If the second number is x, what's the third number? Well, it's got to be one bigger than the second. And if the first number and the second number is x, what's the first number? It's got to be one smaller. Why is that better? Well, because you're going to be multiplying conjugates. And some of you should be getting pretty darn good in multiplying conjugates. We've had a lot of that. Then you can go ahead and distribute. That has to equal 990. So you get x cubed minus x minus 990 equals 0. Well, that's different than the one on the left. So I should get a different answer. Now, does that make sense that I get a different answer? Let's make sure I get a different answer. So y equals, turn off y3, I just used that one. And y4 is the one that we're working with now, so I'll press enter and graph. And I find out that it crosses, oh, it's hard to see, but it crosses at 10. It's right at the very end. I could do a window change and change my y or my x max to, say, 15 just to get farther out. But you can see it crosses out there. It crosses at 10. So in this case, it looks like x is 10. Well, does that make sense? It should make sense because x stood for the second number. And you can see my second number over here was 10. And then what's x plus 1? Well, that would be 11. And what's x minus 1? That'd be 10 minus 1, 9. So I'd still have you prove over here synthetically. I'd have you, take your 10 with your 1, 0, negative 1, and negative 990. Oh, there you go. Almost made it there. 99, you get 990, you get 0. Show that you get 0, and we're ready to roll. Last one, I'm not going to go through the whole thing. I'm just going to say, all right, let's see if we can get this set up. 3 consecutive odd integers. How would you write 3 consecutive odd integers? One example would be 1, 3, 5. Those are consecutive odd integers. So you could say the first, second, and third look like this. X plus 2, because 3 is 2 bigger than 1, you're going to go up by 2's. And x plus 4. That will give you x as your first number. That's not the cleanest way to do it. What's the cleanest way? Did you learn anything from up above? Cleanest way is to say, let the second number be x. Then what's the third? X plus 2. What's the first? X minus 2. Then when you go ahead and multiply them, you've got those conjugates. We've become so adept at multiplying. Distribute, and that has to equal 3315. So bring over the 3315, plug it in your calculator, see what you get for an answer. I can't remember if I plugged that one in or not. I'll check. I gotta work my way down here. There's Y4, Y5. I do have Y5, so I did put it in here. I'll turn that one on here quickly just so we can, if you want to test to see if you can get the answer, you'll know what it is for sure. So graph. Oh, way at the end? Oh boy. It's looking like it's way at the end over here at 15, so I'm going to hit table just to make sure that that works. I'm going to go down to 15 and see if that is true. And there it is. 15 is a 0, so 15 is our x. So on this one, you should have answers of 15, 17, and 13. If you would have solved it over these, you would have got x is 13, then you would have had to add, get 15 and 17. So please make sure that you take the time to run your x through the synthetic, because that's what I'm expecting on the test. So, thanks for watching. Have a great day.